Hi, I'm Entao Gong from Physics 1A. Today I just want to talk about the Chapter 9 discussion about the center of the mass. So let's say this is our graph for the triangle. So there's three vertex 0, 0, 1, 0, and 0, 2. First, we need to find the equation for this line, the hypothesis. So we just do simple math, y equals mx plus b. So this is the slope is run over rays from here. And then the y-intercept is 2, so plus 2. So that equals to y equals to negative 2x plus 2. And this is given also. So to find the center of the mass, we need to do the mass first. Mass of the triangle first. So for mass, the equation should be mass equals density times area. But from here, we need to first use there's a lot of rectangle that make up the triangle. So we need to calculate the area from that rectangle and then times it to the density. So we get here, and then we can use double integral to solve the total mass, which is mass equals double integral of density times the delta of area. So we have, this is the x boundary, this is the y boundary. X boundary is 1, 0 because it's 1, 0. And y boundary is negative 2x plus 2, which is this point here, the highest point, and then minus here, which is 0. So that's our double integral, and this is given for the density, so we just plug it in, and delta A is equals to delta y times delta x, because for the area of this is the area of the rectangle. So rectangle is just length times width, so it's just length times width, but it's changing, so it's delta y times delta x. So we do math, we just do direct integral, and then plug in this value, and then you should get 8 over 3. Yeah, for our next step, then we can calculate it, what's the center of the mass, x dot y. First of all, we need this equation. X equals to mass mx over m. This is the total m that we just calculated. So we can drive the equation to 1 over m times mx. It's the same. So what's mx? Mx is just the total moment of every point about x-axis. So it's about to calculate the x, so you need to put the x inside the double integral. So also same here, density times area, but it's respect with x, so you need to put it here. So this is the double integral for the mx, and my also it's the same. So now we can calculate it. We can calculate the center of the mass on x coordinate and center of the mass on y coordinate. So this is 1 over m. Same with the equation. Okay, I'll just write down here. X equals 1 times m x p x y delta a. So this equation is here, and this equation is here. So we just simply put all the information in, and then it's x times 1 plus 3x plus y, and then you get x plus 3x squared plus xy, and then you do the integral, and then you plug this value in, and then you get here, and then 1, 0, and then you also do the integral, and then you plug the 1 and 0 in, and then you should get center of the mass for the y coordinate is 3 over 8. And then for y, you also do the same. It's 1 over a divided by 3. And then for this, you need to multiply the y because it's in respect with y, so it's equation here. So it's y plus 3x y plus y squared. And then you do the integral and then minus this, plug in this volume. And then this is the first part of the integral, and then second part 1 0, and then you also do the integral here and then plug in the volume 1 and minus the volume of 0, and then you get 11 over 16. So you just put it together. So the center of mass is 3 over 8 dot 11 over 16.